Review 4, question 1. Use the guided visualization to answer the question. So over here on the left side of your screen is the GeoGebra app that we're going to use. And it says use the slider to move the point at 1, 0. So down here where it says drag me, you're going to move that point, and it moves it counterclockwise. Move the point in a counterclockwise direction. After doing so, notice the points that are traced out. So you'll see this red tracing as we do this. The x-coordinate of the point represents the angle, and then the y coordinate represents the y-coordinate of that point corresponding to the angle. Okay, so for example, when I drag this and I go to pi over 2, which is right here, okay, this point, its y-coordinate, which is 1, represents the y-coordinate of when the angle is pi over 2. The y-coordinate is 1, because right there in the unit circle, that's 0, 1. Right? And so that this traces out, this is telling you, it's the same as like the height of the Ferris wheel. It's telling you what your height is with relation to the midline. So you see my height right now, my y-coordinate's 0. That's because I'm right on the midline. All right. So to answer this question, it says, as the angle increases from 0 to pi over 2, all right, the value of sine increases from 0 to, well, you're looking at the y-coordinate. So the y-coordinate's 0, the y-coordinate on the blue dot, and it goes from 0 up to 1. So that's my solution for the first one. All right, the graph of sine x is symmetric with respect to the, all right, so this is in your reference sheets. For question 2, you open up the visualization and it says check the box that says show graph. Notice that the graph of the sine function continues indefinitely in both the negative and positive direction, suggesting the domain of the sine function is all real numbers. Now hit the reset button, which is this right up here. All right. And in the upper right hand corner, uncheck the show the unit circle. So we're going to uncheck that. And check the boxes show graph and show key points. Okay, the graph of the sine function is symmetric with respect to the blank, and the sine function is a blank function. All right, what we learned about this was the sine function is referred to as an odd function, and it is symmetric with respect to the origin. So basically what that means is if you take the sine function and you rotate it 180 degrees about the origin, so what symmetry or an odd function is, if I take this and I spin it around this point here, the origin, all right, it will look the same after I spin it 180 degrees. Okay, so I can't quite spin on this, but I can rotate it 90 at a time. So there's 90 degrees. And now from there, I'm going to rotate it again 90 degrees. And you see it fits, it's the same. So that makes it an odd function. So my answer here, it is symmetric with respect to the origin, and that is referred to as an odd function. Okay, now we're going to, again, launch the figure. All right, number 3, check the plot function box to graph f of x equals sine x. So up here in the upper left, I'm going to choose sine x. Use the A slider to graph f of x equals 5 sine x. Okay, so when I move this from 1 to 5, all right, the value of A affects the blank, right? So we want to, first of all, we want to plot sine. So I'm going to set this back to 1 and say plot the function. Okay, now what I'm going to do is move this to 5, and you can see what it's affecting. Okay, that is affecting the A value, affects the amplitude. All right, we're going to do the same thing with cosine, and we're going to use the A and the B sliders to graph 3 cosine 4x. Okay, select the cosine function. So I'm going to move this to cosine, and I'm going to hit plot the function. So there's our cosine graph. We're going to move the A slider to 3. So that's going to increase the amplitude to 3. And then we're going to use the B slider and move it to 4. All right, and the value of B affects the blank. All right, so when I do B and I move that to 4, all right, that affected the period of the function. This period right now from high point to high point is 2 pi. When I move this to 4, now the period from one high point to the other is only pi over 2. So the B value, okay, is the frequency, and that's going to affect the period of the function. All right, as this gets larger, the frequency, the period gets shorter, gets squished together. Okay, so and what that foretells you, if you count the number of cycles of cosine right here. So if I took this graph, copied it, and I'll just paste it down here. All right, so this first one was 3 cosine, and the second one here was 3 cosine 4x. All right, so this has a period from hilltop to hilltop. That length is 2 pi. That's the normal period for cosine. But when you look at this one now, its period is pi over 2. So it got horizontally squeezed. The 4 tells you the frequency. So what that means is you're going to be able to fit 4 cosine curves. There's 1, 2, 3, 4. 4 cosine curves fit between 0 and 2 pi. That's what the frequency is. Our solution is, these are your 4 choices. The B value affects the period. Here it made the period shorter. All right, select the cosine function, check the plot function box, and graph f of x equals cosine x. And then use the A and the B sliders to graph 4 cosine 3x. So what I did over here so we can compare, this is for cosine x, and this is for cosine 3x. How many complete periods are on the interval from 0 to 2 pi? Well, that's exactly what the frequency tells you. There is going to be 3 complete periods between 0 and 2 pi. All right, so here's 0, here's 2 pi. So there will be 3 cycles of cosine between those 2 marks. All right, so you can clearly see that over here on the left, this is normal cosine. There's 1 cycle of cosine between 0 and 2 pi. But over here, there's 1 cycle there, there's another one, that's 2, and then there's our final one, 3, and that's what that number is telling you right there. So my answer to this is 3. Okay, number 6 is determine the amplitude in the period, okay, without graphing. So we know that since 5 is in the position of A, this affects the amplitude, right? There's nothing in front of the x, so the period stays 2 pi. And my amplitude is 5. And so all that means is this height here would go all the way up to 5. That's how tall the hills would be. So amplitude 5. All right, and the period is 2 pi. All right. Next question is graph 6 cosine x. So we click on the graph. It's a cosine graph, so I click the cosine, go to the origin, and that graphs a cosine. Now I want to take the amplitude and change it to 6. Oops. And there's my graph. All right, our next question is to graph y equals cosine 3x. So we know our amplitude is going to be 1, because that's what A is right here. A is 1, and our frequency is 3. So our period is equal to 2 pi divided by 3. All right, so when I draw this, we're going to see 3 cosines between 0 and 2 pi. All right, so we're going to pick a cosine, boom. The amplitude is 1, but now the period is going to be 2 pi divided by 3. And there's our graph. So when you look at this, we should see 3 of these curves. So there's 1 period of it, 2 periods, 3 periods of cosine. That's what that's telling you. Okay, the second part of this question asks, what is the domain of cosine 3x? Well, the domain of any cosine graph, since it goes all the way, it keeps extending to the left, that's negative infinity, and it keeps extending to the right, that's positive infinity. So my domain is going to be from negative infinity to positive infinity. And in interval notation, we write that as parenthesis, okay, negative infinity, comma, positive infinity, and then we close the parentheses. That is our domain. Then it says, well, what's the range? Well, the range is how high and low it goes. Okay, so the lowest value on this graph would be the graph where it touches y equals -1, and the highest value is 1. So we express that range, okay, since the graph touches these lines. All right, we're going to include -1 and 1 by using brackets instead of parentheses. All right, and then when you type it in over here, just be careful. You got a comma in between. I put a period, and it'll mark it wrong. It's supposed to be a comma. And there's my solution. All right, now okay, I just got to match up my graphs. All right, so let's see. This is that is a cosine graph. So all you're going to do here is just look at your graphs. Here's your reference sheet for that. So I've got it looks like, let's copy this. All right, we've got to match the graph with the equation here. All right, so sine x, there's our positive sine x curve right there. So I can see that that is going to match up with C. So I know 1 goes with C. All right, 2, cosine x. There's our positive cosine x graph. So that is going to match with A. So 2A. All right, negative sine. So negative sine right here dips down and then up. So that would be B. So 3 is going to go with capital B. And then that means that 4 goes with D by process of elimination. Okay, and that's here's what a negative cosine looks like. So 1C, 2A, 3B, 4D, our solution is C. Okay, this question is asking us to choose the graph y equals sine, okay, x plus pi over 2. All right, now we know that when we have a plus in the parentheses, okay, that is going to slide the graph to the left. We call it bizarro world. Right? So what this is going to do is it's going to take the normal sine graph and move it pi over 2 units left. So we're going to slide left pi over 2. All right. So I'm going to draw a normal sine graph, and if you look at these numbers here, well, let's do this one right here. So a normal sine graph would look like this. Do a better job there. That's pi over 2. There's pi. 3 pi over 2, 2 pi. That's a normal sine. And if I take that and I slide it 1 square, which is pi over 2, that's my new graph. So there's a normal sine, slide it left, pi over 2, and there's my answer. Right. So remember when we graphed these, that was 2 pi, this was pi, this was pi over 2. And you can see it's just the graph slid over 1. So my choice is B. All right, now we're going to take the cosine and we're going to slide it pi over 2 units to the right. All right, so our shift here, minus pi over 2, means you're going to take a cosine graph and you're going to slide it pi over 2 to the right because of the minus. Minus pi over 2. All right, so if I took here's a regular cosine graph right here. So I'm going to take that. Remember, each box, if this is pi over 2, or pi, 2 pi I mean, then that's halfway, that's pi. Half of that is pi over 2, and that makes this 3 pi over 2. And if I take that and I shift it pi over 2 to the right, it's going to move over 1 box. So I can see my answer is going to be A. All right, our next graph is y equals 2 plus sine x. So that is going to take a regular sine graph and move it up 2 places. So if I was to draw a regular sine graph on one of these, whoops, I'm just going to slide it 2 places up. So if I took that graph there and slide it 1, 2, that's what it's going to look like. Okay, and that matches this one right here. So I'm taking that graph, 1, 2, and there's my solution. It slid 2 up. All right. Okay, the function graph is in one of these forms where d is the least positive value. So it's, remember, d is how much you move it up or down. Determine the equation of the graph. Well, just by looking at it, we know that this is a cosine graph. All right, and there's my graph shapes right here. Cosine graph, and it looks like it's been slid up. All right, so a normal cosine, if I drew a normal cosine on here, so I'm going to take this graph and trace it and put it back where it used to be before it got moved. All right, so a normal cosine would look like this. Okay, its amplitude is 1 and its lowest is -1, And if I take that and I slide it 1, 2, I get my graph. So this is going to be sine x plus 2, but I think that you want to write it like this. So we're going to type it in as y equals 2 plus sine x. Okay, that was 13. Okay, 14, find the period. So we know our period is equal to 2 pi divided by the frequency. So this is 2 pi divided by 5. Next one is 4 cosine x. What is the period? Well, the frequency, since there's nothing there, there's really a 1, so b is equal to 1, so my period is 2 pi divided by 1, which is just 2 pi. So it's not getting squeezed or stretched out horizontally. All right, our last one is Ferris wheel problem. Okay, Ferris wheel makes one complete turn every 50 seconds. So our period is 50 seconds. All right, to get our amplitude, we got to do our highest and our lowest positions on the Ferris wheel. So the low would be 6. The radius is 30. So from the low point to the middle, that would be 36, because I'm adding 30. And now I'm going to add 30 more. And my high point is going to be 66. All right, so my amplitude is going to be 66 minus 6 divided by 2. So that's 60 divided by 2, which is 30. My vertical slide, or midline, I'm going to take the highest, which is 66, add the lowest, divided by 2, so that's 72 divided by 2, which is 36, and that's our D value, and our A value is 30. Remember, D is the same as the midline, or the vertical shift. Midline and vertical shift are the same thing. All right, now we got to get the frequency. So the frequency, we're going to take our period, which is 50 seconds, and to get the frequency, we're going to do 2 pi divided by 50. So those reduce to pi over 25. So that's going to be our B value. Okay, now to get our C value. So we take our period, which is 50, and we divide that into 4 pieces. Okay, so 50 divided by 4 is going to be 12 and a half. Okay. All right. So what that means is, on our theoretical sine graph, at 12 and a half, there should be the first max. All right, now to get our C value, we took 50, we divided it by 4, and we get 12 and a half. So a regular sine graph would look like this. Remember, sine starts at the origin, then it goes to its max. It's going to have its first max at 12 and a half, then back to 0, then its first min, and then back to 0. So its first max happens at 12 and a half seconds. Okay, and that would be 66 feet. The midline is 36 feet, and the low point is 6 feet. Now, what the actual Ferris wheel's doing, 66, 6, 36, is that you're starting here. So the Ferris wheel is starting at 6, and then it's going to do its sine curve. Okay, so its first max doesn't happen until 25. So in order to get the theoretical max to match up with the actual max, we've got to add 12 and a half. Okay, so that is going to be our value of C. All right, and I think we would probably leave that as a decimal or as a fraction. So if we did 50 divided by 4, okay, that becomes 25 over 2. So we would use 25 over 2 here instead of 12 and a half. Okay, so if this graph right here, if I shifted it over 12 and a half, now it's going to match that graph. So our A value, and I don't even think it asks for that, to be honest with you. This one just asks for A, K, and theta. You didn't have to do the phase shift. So you don't need to worry about that. All right, so our A value was 30. Okay, the midline was 36. And our frequency was pi over 25. And that's all you had to do here. You didn't have to do, so I did a little bit more than you had to. So this is pi over 25. And that's it. Okay, good luck on your tests.